Mm-hmm. This one up.
We're getting some. Oh, I'm on. I know your name's not on.
You got me on that?
Oh my gosh. Imagine if you started tickling me. Like, serious.
Something tells me somebody's doing a payment, and I think I would end up in somebody's home. Just saying. I think you and I will finish
We end up in Mike's office.
I would end up somewhere.
You would end up somewhere.
I would end up somewhere.
Literally anywhere.
All right.
You can do 10 for 100 people. All right, when we're handling a cone, there's a huge difference between volume and surface area, which is what? What's the difference between a cone and with volume? That's huge. Which is huge. What is surface area involved that volume does not, or vice versa? Wow. Okay. So basically, when it tells you the slant height, if we wanted to do surface area, we wouldn't need trig. Well, we would still, because we would need the length of the slant height. But the idea is the slant height and the height make what type of triangle in a cone? A right triangle. Now it says it makes a 72-degree angle. That 72-degree angle is anywhere. That comes from the property of a circle. So whether you drew it to there, there, or there, it wouldn't matter. Does that make sense, everybody? So that's my 72 degrees right there. All right, so they tell me the circumference of the base is 24 pi centimeters. Everybody good with that being 12? Make sense? Okay, so we need volume. So there's the height, there's the slant height. Which one do we need for volume? Height. I don't need the slant height. I don't need the hypotenuse, so which trig functions it got to be if hypotenuse is involved? Tangent. So the tangent of 72 degrees equals the opposite, which is h, over the adjacent, which is 12. So I'm going to use my knowledge of trig at this point to do 12 times the tangent of 72.
That's 36.9.
No, I'm just gonna take that knife.
What do you need, brother? A knife? Go right ahead. Gonna cut someone? Someone getting shanked?
Something.
Someone getting shanked?
I like to change. Thank you for your help.
Hey.
So now volume equals 1/3 because it is a cone. Pi 12 squared. All right. times the height we just found to be 36.93. When I plug everything in,
Is that right?
144 pi divided by 3 times 36.93. And we get 5568, and depending upon where you round it to, 9 or 91 centimeters cubed. Are you still looking for a knife? Ladies and gentlemen, that would be Mr. Capella, the
Hello.
world-renowned English teacher, and Shanker. Enjoy your John. Yes, sir.
I think, for some reason, I think that we, forgot to divide by 3. Twelve squared times, oh, wait. Pi.
I'm still getting
I
the
thought
same
we were
answer.
around it.
Michael, never think you're don't do it to yourself. Don't do it to yourself. Yes, ma'am.
Figure it out. I thought we were around it. I thought we were exact.
If it doesn't say in terms of pi or exact, is it always, not like?
Oh, the only time you round is when it tells you to round. The only time you round is when it tells you to round. Now, some coordinate geometry. So this is a three-dimensional representation of when they rotate about an axis. All right? So this is my x-axis, and that's my y-axis. Okay, if that's my x-axis and that's my y-axis. All right? Whatever I rotate about, I'm actually going to erase that. Whatever I rotate about, so in this case, I'm rotating about that axis, you see? All right? Whatever I'm rotating about becomes my height. And whatever the other coordinate is becomes the radius of my shape. And then you can see what happens as a result if you don't want to draw necessarily the three-dimensional coordinate grid. You can see a representation of that. So the H is always whatever it's rotated about. All right? And then your radius becomes the opposite coordinate. Okay, now if we look at cones, the one thing you got to keep in mind, all right, one thing you got to keep in mind is if you need the surface area, the slant height is not going to be a coordinate. So in other words, from here to here is 3, that's your x, or your change in x. Here to here is your y, that's your change in y. In order to get your slant height, you will then need to use what, of course? Pythagorean theorem.
Or in this case, special right triangle.
Or special right triangle. Yes, ma'am.
Sorry, I understand what you mean when you said the radius.
So in other words, whatever they give you for the coordinate here, this is a coordinate point. That's got an x and a y. You got me? Okay? So if they are rotating about the y-axis, then the radius is your what coordinate? Got me? Make sense? All right, so what I want you to do is start formulating a plan for the first one. All right, start jotting things down you'll need to know in order to solve the first one.
Find the volume.
Besides Miss Hillman, is there anybody else making up a quiz today after school library?
You think I should make it up today?
It's up to you.
Is it Are you available like?
I mean, I'll be here tomorrow and Wednesday as well. Well, I'll be here tomorrow. Wednesday you can do it. I just have time with you. And then Thursday I'll be in. Thursday, you can make something up if you want. I'm not going to stay for extra hours. But you can make something up.
Okay, can I get tomorrow?
All right. So the one on the left represents when it's rotated about the x-axis. The one on the right represents when it is rotated about the y-axis. Does anybody have any issues about any of those numbers that result from this?
I thought it was I thought the thing was a prism, not a.
When we rotate 360 degrees, Michael, are we going to have a circle?
No. Well, yes, we are.
We are. So these shapes always going to have some type of circular surface. Yeah.
So the one on the right is around the Y.
This is the one around the y-axis. All right. And then this is the one about the x-axis. Any questions? All right. So if there aren't any questions, all right, the 8 here obviously represents the height of the cylinder. That's because it's rotated about that axis. The 3 then represents the radius, because that's the other coordinate. Yes, ma'am.
Yeah, I don't know why, like, it's rotated on the X. Like, I have them backwards for X.
That's why we just told you the idea of where it's rotated about. If it's rotated about the x-axis, it's rotating that way. Rotating about that way. So the easiest thing to do when you do this, all right, the easiest thing to do, for example, when it says rotating about the x-axis, is simply reflect that point over that axis. And then simply connect those with like an arc or a semicircle, and then do that. And that'll give you an idea of which direction the cylinder is going. All right? So that makes the height of my cylinder over here 8, and the radius 3. To get the volume, we plug it in. Pi r squared h equals pi 3 squared times 8. 3 squared would be 9. 9 times 8 is 72, giving me a volume of 72 pi. For the one on the right, rotating about the y-axis, the 8 and 3 switch roles. So pi 8 squared times 3, 8 squared is 64. 64 times 3 is 192. Notice, are their volumes the same? No, they are not. If I do surface area is 2 pi r squared plus 2 pi r h. All right? The radius is 3. The height is 8. 3 squared is 9. 9 times 2 is 18. 8 times 3 is 24. 24 times 2 is 48. 18 plus 48 is 66 pi. For the one on the right, all right, the 3 and the 8 switch roles, so 2 pi 8 squared plus 2 pi times 8 times 3. 8 times 3 is 24. 24 times 2 is 48. 8 squared is 64. 64 times 2 is 128. Add them up, I get 176 pi. Notice once again they are different. However, what is the same? The lateral area is exactly the same. Good. So that means the change is created by the base. And that is because what? Here, what number is being squared? And here, what number is being squared? 3.
That's really going.
So which one has the greater impact on a change in your volume, the height or the radius? Why? Because the radius is being squared in the first part. All right? Now, if we go down and we talk about rotating the triangle, if we rotate it about the x-axis, this is what we got. We take that point and reflect it over that axis. So that comes down here. We reflect that segment as well. That gives us our triangle, and we connect it to form our general shape of our cone. The volume involves 1/3 pi. The radius is the opposite coordinate. Since we're rotating about the x, we're talking about the y coordinate. What is the y coordinate? 5. So it's pi 5 squared times the height, which is the x coordinate, which is 12. 5 squared is 25. 1/3 of 12 is 4. 4 times 25 gives me a volume of 100 pi. Surface area is pi r squared plus pi rs. The radius, once again, is 5 times pi 5. Where on earth did that 13 come from?
Slant height.
The slant height. And where did the value of the slant height come from? What theorem?
Pythagorean theorem.
Pythagorean theorem or
Again,
triple?
this is special.
Or special right? No. Be careful when you say special right triangle. Triples.
I forget this.
All right. Don't get yourself in a huff. Slow and steady wins the race. Serenity now. All right. 13 times 5 is 65. 5 squared is 25. 25 plus 65 gives me 90 pi. If I then do the second part, which is rotating it about the y-axis, once again, they switch roles. All right. So now the 12 is the radius. The height is the 5. 1/3 pi, 12 squared times 5. 12 squared is 144. 1/3 of 144 is 48. 48 times 5 is 240 pi. Units cubed. Whenever working with these, just use units as your label. Surface area would be pi r squared plus pi rs. The radius is 12. Pi 12 squared gives me 144 pi. 12 times 13 gives me 156. 144 plus 156 is 300 pi. Units squared. Yes, ma'am.
When we take a quiz on this, are we gonna?
I don't know. I don't know. And I'm not going to answer that question because you should learn what to do and then worry about the quiz after. I'm not teaching you a quiz. How's that? Okay. Are the values of the volumes and surface areas the same? Why or why not? The short answer to that would be, by the way, I don't know because I haven't written it yet. All right. Are the values of the volumes and surface areas the same? Why or why not? We've already realized no. Because the role of the what switches? The radius and the height. Good. And this goes to Michael's point. Can we create a polyhedron while rotating about an axis? Why or why not? No, because what is a polyhedron contain by definition? In the beginning of a polyhedron, all the surfaces of a polyhedron have to be what? Polygons. Once we rotate, what are we going to have? Circles. Okay? Everybody good? Okay. So now you guys are getting to talk. And my period one got on Friday, and then we're done for the day. Everybody good? Everybody knows what to do tonight. 11.4 practice. What's due tomorrow night? 11.5 practice. Okay. Time to put on the books. Otherwise, people think I'm an angry person. Okay. So,
So the polyhedron must contain, must have a shape, must have, what was it?
polyhedron has to have polygons. All right, everybody put everything back.